Let's talk horizontal asymptotes or oblique asymptotes or no asymptotes, or can you have a parabola asymptote? I don't know. Let's find out. Let's take a look. I think a good way to start is just domains. I think it's just always good to factor and take a look at what's going on in the domain. But then we'll just go right from there into those horizontal asymptotes and some other ones too. If you factor this one right here, the first r of x that you see, you probably recognize difference of squares makes conjugate pairs, as I like to say. Cool. And we could see the domain says that x cannot divide by 0, can't cause divide by 0, plus or minus 2 of those problems. So if I was to graph this, both of those binomials are left in the denominator. We're going to have vertical asymptotes. If they simplified, they create holes where they are canceled. I'll make another video for that one later. But right now, if they remain in the simplified form, there's no binomial in the numerator to cancel, is what I'm saying. So this is simplified. Then we would have -2 and +2 as our vertical asymptotes. But what about the horizontal asymptote? What about that horizontal asymptote? Well, I always like to focus on the degree. Technically, this is a degree 0 on top, and a degree 2 on the bottom, So if I plug and chug a large number, horizontal asymptotes and oblique ones are asking what is happening as x goes to positive infinity or negative infinity, which means I'm going to plug and chug a big, huge x value, like 1,000,000. Well, if I took 1,000,000, which is 10 to the 6th, right, and I put that in for x, I would have 1 over 10 to the 6th squared. That's 10 to the 12th. Now, you know, the -4 is probably not going to do that much. This is 0. This is basically 0. So I know the horizontal asymptote is going to 0. I could check, y equals 0 in this case. Y equals 0. I can check going to negative infinity, but it would produce the same thing. Okay, in fact, it would get squared, and so it'd still be positive. So what we're doing is we're examining how the degree on top and bottom work here. Now, I could tell you straight out, the degree's smaller on top. If the degree's smaller on top in the numerator, you're going to level off at 0, period, straight up. Let's look at h of x here, h of x. I notice that I have degree 2 on top in the numerator and degree 2 in the denominator. First thing I want to recognize. Let's factor it. Let's see if we can factor it. Talk domains, etc. Factoring the top, I see an x. I see an x has been distributed. That looks like it'd leave a 3x plus 1. Let me just mentally check my distribution. Yes, that's right. And the bottom, does it factor? It doesn't. You might think difference of squares. No, it's not a difference. So you're done. There's no factor here. This is a parabola up 4. I think knowing the graph, that denominator right there, just the denominator, is a parabola up 4. Does it ever make 0? Does it ever hit the x-axis? No, it doesn't. It never makes 0. There is no domain error here. There's no vertical asymptotes. There's no domain error. Knowing the parent graph really it speeds that idea up. So let's look at what happens as x goes to big numbers. In other words, let's let x equal a big number. Now, I could tell you degree on top and on the bottom, numerator and denominator the same. There's a rule. But I don't want you to trust me. I want you to see it in action. Let's plug and chug 1,000,000 again. It was fun last time, right? Okay, what's going to happen to h of x at 1,000,000? In other words, what is happening at h of a million? Remember, 6 zeros with a 1 is a million, 10 to the 6th. Well, it's going to 3 times, again, same thing, 10 to the 12th, little exponent rule there, and then plus a million. I want to ask you, though, how does a million compare to 10 to the 12th? Like, if you had 10 to the 12th and you lost 10 to the 6th, did it really affect your numbers? That's a great question. Play around with a calculator if you don't know the answer to that. But the real answer to that is a million is nothing, zero compared to 10 to the 12th. Huge difference. Okay, over 10 to the 12th plus 4. So here's the way it works. There's something called the power function in both the numerator and the denominator. And that's because when you throw in a large number, they're the most powerful thing in the equation. These numbers over here are nothing. Moot. We don't care about them. So let's focus on what's happening to the y-coordinate. As x goes to a million, y seems to be going to 3. I don't know what 10 to the 12th is. Trillion? No, I don't know. I'd have to look it up. But 3 10 to the 12s over 10 to the 12th. And the 10 to the 12th cancels. Ah ha ha. As x goes to positive infinity, y goes to 3. We have a horizontal asymptote at 3. Here's the rule. If your degrees are the same, simplify the two power terms, the most powerful things in the numerator and denominator, and you get your answer. Kind of cool. All right, we've talked about degree lower than on top in the numerator than the denominator. We've talked about the degrees the same. If we look to this one, r of x, the horizontal asymptote is going to be at y equals 0. I'm now trusting the knowledge we gained before. It's a good factoring one to look at the domain just to see the verticals, So let's see, x squared minus 1 and x squared plus 1. Ah, yeah, we got some vertical ones here. I've got verticals at plus or minus 1 because of the conjugates. And you know what? X squared plus 1. I'm not going to get fooled twice. That's a parabola up 1. Nope. No zeros there. So excuse me. So this one has vertical asymptotes. Again, they didn't get canceled. At x equal plus or minus 1. Cool? So this is the idea of asymptotes, both vertical and horizontal. So we've looked at degrees are lower in the numerator, the same in the numerator and denominator. What happens the other way around? What happens if we get a numerator degree that's higher? Let's see. Let's factor this one. Factors of 2 that make 3. Oh, I got it. Cool. I don't need parentheses on the bottom. Just, I felt like I wanted to be inclusive, I guess. I don't know. I think it just looked cooler that way. Vertical asymptote, what makes 0 in the denominator? It's the domain question. So we've got a VA at x equal, what makes 0? 3. We've got a VA at x equal 3. Where is the horizontal? Horizontal, if there is one. Well, let's do that plug and chug a million trick, right? So let's say if x goes to a big number, like infinity or a million, what does this answer look like? What is y going towards? Well, let's see. If I plugged and chugged, it would be 10 to the 6th, or squared, 10 to the 12th. Right, 10 to the 12th. Cool. And plug it in 10 to the 6th here into that x, and I get a plus 2 at the end, but we kind of know that these numbers really don't make that much of a difference. And in the denominator, it's just a million minus 3, and again, the minus 3 is just not to focus on in terms of getting this. you know what? If I looked at just the first two terms, that's a big number. That's a big number. That's 1,000,000 in itself. So this isn't leveling off at a horizontal, is it? All right, let's do a little more exploration then. Let's explore more. Let's look at just the two power terms. I got an x squared over an x. What's that simplify to? X, which is that line. You know, y equals x, one of our lines, mama function from a long time ago, right? Cool? Okay. So that means that this graph is going to follow an oblique asymptote. It's going to come up like right below it or maybe above it. I don't know. More exploration. How do you get it? Long division is our answer. I know that's not the answer you want to hear. Long division is the answer. So the real way to get it, is you got to go x minus 3 divides into x squared minus 3x plus 2. This is a good time for synthetic division if you learn that. I'm only going to show one or the other here, so I'm just going to go with long, but synthetic would be a good time to do synthetic. Okay, I'm going to multiply by an x to get that, and then I subtract, change the signs. Cool, and I get 0 plus 2. And if I ask how many times does x go into 2, it does not go into it. So that's kind of a remainder, and we would write it like this, which, by the way, is a rational graph in itself. Whoa. But look at our main answer. This, as x goes to infinity, this goes to 0. This goes to 0 as x goes to infinity. We've been talking about that. Okay? This is the graph. So this graph has a vertical asymptote at 3, and it has an oblique asymptote that is the parent graph y equals x. So we get x equal 3 and y equals x. And then I got to picture the parent graph in there somewhere. If there's no negatives, my guess is the parent graph kind of got squished here and maybe here. And I would then, if I was to explore this, I would have to plug and chug some points. I would need to know if there's an x-intercept or not, or if there's a y-intercept. And then I would probably be able to determine whether or not the graph actually goes to where I think it goes. But that's where my guess is, because I know mama. And when you know mama, it makes a difference. Last one. Going straight to it. Look at these power functions. Power functions. If I simplified it, x cubed over x is x squared. We don't really talk about things following a parabola, but graphs actually do kind of follow a parabola in terms of asymptotes. You can see it on Desmos if you graph this and look way back. You can kind of see it. This is not important. You would just say no HA and no oblique. No oblique. Okay, so let's just talk about what we saw. Oblique. I can spell oblique. I can. Oblique. Okay, so let's just talk about it working backwards here. If the degree is more than one higher in the numerator than the denominator. In other words, like what we saw over here. 3 versus 1. 3 versus 1. Okay, then there's no horizontal, no oblique. Make that note. If the degree is higher by more than 1, you got nothing. If the degree is higher by just 1, you got x to the first in the denominator, x squared in the numerator. Then you're going to have an oblique one, and you need a long division to find it, or synthetic. If the degree is smaller in the numerator, okay, in both these cases, then you have a level horizontal at 0. Levels off at 0, mainly because the denominator is very strong, and it makes you divide by 0. And if you have the same degree, simplify the power terms, and you'll see where y goes. I hope this has helped.